ఇది రిసీవ్ చేసుకుంటే comments. Okay, ma? Okay, students, is it visible for you? Right, ma. Right, some questions we are going to discuss here. Some questions are there regarding the basic electronic subject. Voice is not clear. Background disturbance is coming. Okay. Now tell me how the voice. Is there any variation? Right, Amma. Right. We don't know, ma, actually when the next KPTCL notification, because exam is 25th, na? Right, ma. Now okay, right. See, I think KPTL students already written the exam regarding this. This is the question given. A conductor collects electrons from the base in case of Pnp transistor, electrons from the emitter in case of Pnp transistor, holes from the base in NPN transistor, holes from the base in case of Pnp transistor. What the collector will collect? Tell me, what would be the answer for this? For this question, what is the answer? I am waiting for your answer. How electrons from the PNP? Just you have to see here. Carefully try to see the question and answer it. Don't answer blindly. What is this one? Which is a PNP transistor. This is a PNP transistor. It's a NPN transistor. It's a PNP transistor. Electrons from the base. Collector will collect. That is okay. Electrons from the base. Electrons from the emitter. Holes from the base. Holes from the base in case of suppose if you take Pnp transistor, this is Pnp transistor. In this Pnp transistor, what we would like you to take? We have a emitter here, base here, collector here. Emitter here, base here, collector here. Now coming to the emitter, what it contains? If it is a Pnp transistor, holes it contains. The holes are coming from emitter to base, and that holes are transferred to base to the collector. Holes are transferred from base to the collector. If it is a Pnp transistor. Tell me, what will be the answer? This is not the valid answer. Why? Because electrons from the emitter in case of PNP is wrong. Because you do in the PNP transistor, you have the in the emitter what we have, electrons we are having. So here electrons are coming, electrons to holes, electrons from emitter. No, this is also not possible. First, what is that? Holes from the base in case of PNP transistor. I think everyone is clear. The answer is D. The answer is what? D. D is the answer. D is the right answer. If you have got any such a doubt, immediately try to draw the circuit diagram and check it. Try to draw the circuit diagram and check it. Okay, ma? Right? Very good, very good. Okay. Next. Coming to the next question. So, a PNP transistor is made up of silicon, germanium, either silicon or germanium, none of the above. Such a simple question it is. A PNP transistor is made up of silicon, germanium, either silicon or germanium, none of the above. Yes, right, right. C is the right answer. It may be made by either silicon or germanium. Why only B? You can manufacture with either silicon or germanium because it is an electronic device. Okay, ma? Right, all of you? Right, next question. What is the next question? In most transistors, the collector region is made physically larger than the emitter region. So why collector is having larger, physically larger? I think you can answer very easily for this. Options are available for dissipation of more heat, to distinguish it from the other regions, as it is sensitive to ultraviolet rays. Okay, what is the answer? The answer is to dissipate more heat. To dissipate more heat. The conductor is made by using to dissipate more heat. Okay, ma? Right? Next question. What What would be the next question? Read the question. In a transistor, the region that is very lightly doped and very thin and lightly doped region. Emitter, base, collector. No. In the case of base, heat will produced is not more. In the case of collector only, heat is more. That's why collector is made by large cross section. Because collector must have a large power dissipation, so that to handle such a high power dissipation, it should be made by that one. Now, I think you all of you know very well, very good answer. The base is having lightly doped as well as very thin among all. Lightly doped and very thin among all. Collector is having large resistance. Because we are making the reverse bias, the collector is having large cross-sectional, large resistance. That's why power dissipation is more. Now you tell me, what is this question? See here, what is the question? Question is, in a NPN transistor, when a emitter base junction is forward biased and the collector base junction is reverse biased, the transistor operates in active region, saturation region, cutoff region, none of this. I think answer easily. Tell me, ma. Right, Sridevi? Answer A is the right answer. Active region. Yes, exactly. This is active region. Suppose emitter base junction is forward biased, collector base junction is also forward biased. That is saturation region. When emitter base junction is reverse biased, collector base junction is reverse biased. That is a cutoff region. For this question, what is the region? Active region is the right answer. I think all are writing the very good. So, conventional biasing of BJT has emitter base forward biased and collector is forward biased. Emitter base is reverse biased and collector is forward biased. Emitter is forward biased, collector is reverse biased. Emitter base is reverse biased and this one. Tell me what is the answer? Yes, ma. Yes. Usually, whatever the previous question we discussed, same question again. Because always we are preferring to operate the device in active region. We prefer to operate the devices in active region. That's why emitter base junction is forward biased, collector base junction is reverse biased. This is the right answer. Next, the common emitter transistor circuits has high gain, low gain, negligible gain, zero gain. It's appearing clearly? Yeah. Always the gain should be high. Always the gain should be high. Which gain is more in the common emitter configuration? Which gain is more in the common emitter configuration? Generally in common emitter configuration, current gain is high, voltage gain is high, power gain is highest. Usually in the case of common emitter configuration, current gain is high, voltage gain is high, power gain is highest. My question is, which configuration is having high voltage gain? Which is having high voltage gain? Which configuration? Which configuration is having high current gain? And what configuration is having high power gain? Yes, voltage gain is highest for common base, current gain is highest for common collector, power gain is highest for common emitter configuration. Common emitter configuration. Isn't that? Clear all of you? Whatever I explained here. Right, Amma. So coming to the next question. Is it clear for you everything? Whatever the question I explained, that is a very important one. Right now, in an PNP transistor, if both emitter base junction and collector base junction are reverse biased, the transistor will operate in, already we discussed, that is cutoff region. Next, this because I don't want to waste the time, already we discussed that question. Next, which of the following statement is true? FET and BJT both are unipolar. FET and BJT both are bipolar. FET is a bipolar, BJT is a unipolar. FET is a unipolar, BJT is a bipolar. Very good, ma. Very good. Very good, my dear students. So this is a very important question also. Answer D is the right answer. FET is a unipolar device. BJT is a bipolar device. FET is a unipolar device. BJT is a bipolar device. Aparna Gowda, right. Ramesh, Santosh. Okay, ma. This is very nice question, ma. Nice question it is. Next two. Now see here. A FET has a very high input impedance, very low input impedance, forward biased PN junction, none of this. Yeah. FET has very high input impedance. Very nice question. FET has very high input impedance. Next two. For small values of drain to source voltage, the JFET behaves like a resistor, constant current source, constant voltage source, negative resistance. Yeah, it acts like a voltage variable resistor. You see here FET characteristics. From here to here, it acts like a resistor. Thereafter, it acts like a current source. In this region, it acts like a current source. Especially for this one, this region. Especially for this region. What is that region? For this region, if you take this region, it acts like an amplifier. In this region, it acts like an amplifier. But here, in this region, it acts like a resistor. It acts like a resistor. Constant current source, this one. Constant current source, this one. No, Sridevi. Both BJT and FET are the constant current source devices. But FET is a voltage control device, BJT is a current control device. Controlling is different source. Both FET and BJT are the current source devices. You got my point? What I told you, got it or not? Actually, what I tell you is, be careful about this point. FET is a, what is that? Voltage controlled current source. Voltage controlled current source. Whereas FET is a voltage controlled current source. Whereas BJT is a current controlled current source device. This is current source. This is also current source. But this one is current controlled. This one is voltage controlled. That point don't forget. Right, Amma? Clear all of you? Right. In a JFET, the primary control on drain current is exerted by. In JFET, primary control of drain current is exerted by channel resistance, size of the depletion region, voltage drop across the channel, gate of reverse bias. the answer? So primary control is what? Yeah, gate of reverse bias. Exactly. When you make the gate is reverse bias, the control will takes place. Not A, D is the answer. Primarily depends upon. A very nice question you see here. After VDS reaches pinch off voltage, VP in a JFET, the drain current ID becomes 0, low, saturated, reversed. What would be the answer? Already the characteristics we written. Already the characteristics are written. Okay, ma. They are saturated because you know once this is a pinch off voltage. Once pinch off reaches, the current becomes constant. As already we discussed this. This is called this point is called pinch off point. This point is called a pinch off point. After the pinch off voltage VP, the drain current is almost constant, which is saturated. Okay, ma? Okay, Aruna? This is already given in 2016. Okay, right. Now, tell me what is the answer? In a JFET, the drain current is maximum when VGS is. All are very nice questions, na? So what is the answer? In a JFET, the drain current is maximum when VGS is equal to 0. VGS is equal to 0. See here how the characteristics will come here. This is the characteristics when VGS is equal to 0. VGS is equal to 0. Thereafter, our characteristics may becomes like this. Characteristics may becomes like this. VGS is equal to minus 1 volt, minus 2 volts, minus 3 volts, minus 4 volts, something like that. Your drain current is decreasing because JFET is operated in depletion mode of operation. Current is only decreasing is possible, not increasing possibility. It's a depletion mode of operation. Answer is 0. Why some students are given different answers? Be careful. Be careful. If you have any doubt, please note down the doubt and again you think about that question, how that answer we got, that gives you some knowledge for you. That gives you some knowledge for you. Are you okay? Appanagowda is given correct answer. Ramesh has given D answer. Naresh. Right, Amma, right. We'll go to the next question. We'll go to the next question. If JFET has a disadvantage of being a noisy, having small gain bandwidth product, possesses positive temperature coefficient, having low input impedance. Okay, ma. Okay, right. Srikanth, sometimes I may not see. Randomly I am seeing the names. If you are given, you are also very good. Yeah, only one and one disadvantage of the JFET is, only one and one disadvantage of the JFET is small gain bandwidth product. This is only the disadvantage. Gain bandwidth product is less over the BJT. The BJT, as compared to the BJT, this is only the question what we are having. Okay? All are you are answering very nice. Keep it up, keep it up. Keep it up. The drain to source voltage at which the drain current becomes nearly constant is called barrier voltage, breakdown voltage, pickup voltage, pinch off voltage. Examiner, pickup voltage is also given. Pick off voltage, pinch off voltage. Tell me, I am waiting for your answer. Yeah, nice ma, nice. What is that? Pinch off voltage. Pinch off voltage. That's what before question we discussed this. After pinch off the drain current became constant. After the pinch off the drain current becomes constant. A depletion MOSFET differ from a JFET in sense that it has no channel, gate, PN junction, substrate. How substrate? Yeah? You are having MOSFET is having substrate, JFET. Only thing is insulated gate it has. MOSFET is having insulated gate. MOSFET is having insulated gate. remaining PN junction will be there in JFET and MOSFET. Substrate is there, channel is there. But depletion MOSFET means it is a MOSFET, it is the JFET. Reason is insulated gate. Okay, ma? Answers. Okay, ma? Yeah, now tell me. For the operation of the E MOSFET, enhancement MOSFET, N channel MOSFET, the gate voltage, it is not gain ma, the gate voltage will be positive, negative, zero, none of this. See ma, for example, you try to see what is this. This is N channel, N. So to increase the current, to increase the enhancement means to increase. To increase the current, we have to produce the negative charge carriers here. For negative charge carriers. To create negative charge carriers, we have to give the positive supply to the gate. Positive supply to the gate. Next question. MOSFET is basically what? Tell me what is the MOSFET is basically? MOSFET is basically a capacitor. MOSFET is basically a capacitor. Yes, that is for N channel. Puja, that is for N channel. For P channel, we have to take the reverse. Hanumanth Gowda, not resistor. Not resistor. It's a capacitor because MOSFET. During ohmic region, FET behaves like a resistor. During ohmic region, the FET behaves like a resistor. But whereas here, it acts like a capacitor. Basically, it is a capacitor. Yeah. Which of the following leakage current is high? ICB not, IBE not, ICE not. Tell me answer. Tell me what is the answer? So which is more? ICE naught is more. ICE naught is equal to 1 plus beta times of ICB naught. In common emitter configuration, reverse current is more. Because of that, thermal runaway problem will come. ICE naught is higher. I told you in the class also. Next, see here, what is that? The drain to source current in JFET is given by actually these are all multiplications. Not into, these are all multiplications. IDSS into 1 minus VGS by VP whole square. I think two answers are looking same. The answer should be like this: 1 minus VGS by VP whole square, like this. IDSS into 1 minus VGS minus VP whole square. IDSS is equal to ID is equal to IDSS into 1 minus VGS by VP whole square. Are you okay? But here there should be some difference. ID is equal to IDSS into 1 minus VGS by VP whole square, like this. This is the correct answer. Okay, ma? Right? But we have to follow carefully. Unity current gain is obtained in which of the following? Common base, common emitter, common base, common collector. Unity current gain. Current gain is unity. Actually, from the drain characteristics, FET follows the parabolic characteristics because it is a square law scale. It's having a square law scale. Common base configuration is having nearly 1. Alpha is nearly 1. Unity current gain. Isn't it not? Unity current gain. Very good. Very good. Next, when a transistor is used as a switch, its operation is confined in cutoff region, saturation region, active region. Both A and B are available. When a transistor is used as a switch, the answer? Yes, ma. Yes. So both A and B is the answer, because in saturation region it is a on switch. In cutoff region it acts like a off switch. In active region it acts like an amplifier. It acts like an amplifier. All these points we discussed in our regular classes. I given a clear table for you and we discussed very clearly. Yeah. Thinnest region in a BJT is? Thinnest region in a BJT is? Tell me. I am waiting for your answer. Base is very thin. Base is a very thin layer among all the layers. Base is a very thin layer among all the layers. Next. What would be the next question we can go? See here. Which of the following expression for leakage current in a CE mode is false? False statement is asking. Be careful. False statement is asking. So actually ICE naught is equal to 1 plus beta times of ICB naught. 1 plus beta is nothing but gamma. Gamma is nothing but 1 by 1 minus alpha. Gamma is nothing but 1 by 1 minus alpha. 1 plus beta is nothing but gamma. So this answer is correct answer. Answer means the relation is valid relation. This relation is also valid relation. This relation is also valid relation. Which is an invalid relation, you have to see. And IC is equal to beta times of IB plus ICE naught is also be the relation. From this what is written? ICE naught is equal to IC minus beta IB. This is also the right relation. This is only the wrong option. So false option is this one. This is the correct answer. D is not wrong, ma. D is not wrong. IC is equal to beta times of IB plus ICE naught. ICE naught is equal to IC minus beta IB. This one and this one are equal. This one are equal. D is not wrong. B is the wrong answer. So that is the correct answer for this question. Right? Everyone is clear? Here 1 minus alpha is the right answer means 1 plus alpha is a wrong answer. 1 plus alpha is a wrong answer. Right, ma? Next. Be careful about this type of questions. That will take some time. Which amplifier has the high current gain and low voltage gain? Which amplifier has the high current gain? High current gain and low voltage gain. High current gain is for CC, highest current gain. Low voltage gain for CC. CC, which is having high voltage gain, low current gain, which is having low voltage, high voltage gain and current gain. Okay ma, okay. AE online we will try for that. Sure. Right? Next. The configuration which has highest power is the configuration which has highest power gain. This is a very beautiful question. All the questions are rotating in that area only, na? Power gain is highest in common emitter. Already we discussed that. This point also already we discussed. For an amplifier, the J effect is operated in ohmic region, pinch off region, breakdown region, none of this. Pinch off region, it acts like a amplifier. I already given a data also regarding that. Next, in a J effect, mu, Rd, Gm are related to. Mu is nothing but voltage gain, Gm into Rd. Mu is nothing but Gm into Rd. This is the gain. Next, in a transistor, B is expressed in terms of alpha, beta is expressed in terms of alpha. Beta is equal to alpha by 1 minus alpha. Beta is equal to alpha by 1 minus alpha. Right, Amma? Next question. In a transistor, IC is equal to 100 milliamperes, IB is equal to 0.5 milliamperes. The beta of the transistor is beta is equal to formula 80. What is beta is equal to? IC by IB. IC by IB. 100 divided by 0.5. What would be the answer? 200 is the beta. 200 is the beta. Right, all of you writing the correct answer. Nice. If alpha is 0.9 and the beta of the transistor is 0.9, 0.09, 990. So what is the beta is equal to? Beta is always greater than 1. This is wrong, this is wrong. Only these two we have to decide. Beta is equal to alpha by 1 minus alpha. Alpha is how much? 0.9 divided by 1 minus 0.9. So what is this becomes? 0.9 divided by 1 minus 0.9 is how much? 0.1. So 0.9 divided by 0.1 is nothing but 9. Okay, ma? Clear, ma? 9 is the answer because this is the relations. This is the formulas. All the relation you have to remember to answer carefully. This is for JE and sub-engineers, which is very, very useful questions. Of course, for AE level also, theoretical questions are common to this category only. The voltage gain of an amplifier is lowest in. The voltage gain of amplifier is lowest in CB configuration, CE configuration, CC configuration. Which configuration? Voltage gain is least in common collector configuration. Least in common collector configuration. Least in the common collector configuration. Next. The input and output of a CE configurations are the input and output of a CE configurations are 180 degrees out of phase. The input signal is like this for common emitter configuration. Output will have the signal like this, which is 180 degrees phase shift. Input and output will have 180 degrees phase shift. I think you know very well. Is it or not? Next. Next question. The figure represents NPN transistor, PNP transistor, Zener diode, power diode. Of course, it is a transistor. NPN. Always the arrow is from P to N. Always the arrow is P to N. If it is a PNP transistor, the arrow should be inside like this. But it should be a emitter. Compulsory, it should be a emitter. It is collector. So this is for PNP transistor. And what is the Zener diode symbol? You know. Yes, ma. Yes. Next. Right here, common emitter transistor has high current gain and voltage gain, low current gain and voltage gain, high current gain and low voltage gain, low voltage gain and low current gain. Already, how many questions are came based on this one? You can observe. So many questions are related to the similar representation. What is the answer? Because of common emitter configuration, high current gain as well as high voltage gain, power gain is also highest. Power gain is also highest. Yes, both current gain and voltage gains are high. I given a table for you in the class. I given a table. From the table only how many questions are framed you can see here. Even in the latest JLM exam, also 2 questions what are there here. Which of the following has high voltage gain, high current gain, high power gain? That question is given. Symbol for NPN, PNP transistors are given. Yes. Next. For a transistor alpha is equal to 0.98, emitter current I is equal to 2 milliamperes, IC is equal to, for a transistor, IE given, IC we want to find out. How to get that? I think approximately without solving the problem, we can write this one. We can choose that answer is that one. What yeah. How I answered that C? How I answered that C? Collector current is approximately equal to emitter current. See here, it is very away from the emitter current. This is also away from the emitter current. It never, because collector current never be greater than emitter current. Only near to that one and less, 1.96 milliamperes. 1.96 milliamperes. Yeah. Next, a JFET can operate in depletion mode only, enhancement mode only, depletion and enhancement mode, neither depletion nor enhancement mode. JFET always operated in what mode of operation? JFET is operated in what mode of operation? JFET is always operated in depletion mode only. Depletion mode only. Next. A bipolar transistor is a dash control device. FET is a dash control device. BJT is a current control device. FET is a voltage control device. Current and voltage. Current and voltage. Already I discussed this point in the same session. In our same session. In a BJT, ICB naught is equal to 1 microampere, alpha is equal to 0.99, the value of ICE naught. ICE naught is equal to 1 plus beta times of ICB naught. 1 plus beta times of ICB naught. What is that? 1 plus beta times of IC naught. What would be the beta? Beta is equal to alpha by 1 minus alpha. Alpha by 1 minus alpha. 0.99 divided by 1 minus 0.99. From that you calculate beta, substitute that beta is here, multiply with ICB naught. I hope without solving all these things also, we can tell the answer. Without solving all these things, we can tell the answer. How, sir? Yes, because your ICB naught is 1 microampere. ICB naught itself 1 microampere. IC naught is nearly 150, more than 50 times, something like that. I think it is 100 microamperes. It is what, 100 microamperes. Okay? Next to Emitter. Okay. So take a small break, Amma. Okay, take 15 minutes break. We will continue with rectifiers. Questions on rectifiers. This is the idea about the JFET and MOSFET as well as BJT. Take a 10 minutes, 15 minutes break, and we will continue with the rectifiers. After rectifiers, we will go for, depending upon the time availability. I think continuously watching you may get bored. But you are going to involve, na? Actually questions, na? That's why. No, this is not a FET. What is this? Rectifiers, filters, biasing. Rectifiers, filters and biasing. All together. Biasing is also available here. Okay, ma? Take a break. Again you join. Now what is the time? 5:20. We will start the session at 5:40. Please join all of you for 5:40. Okay, ma, bye.